Now coming to the second part of the compilers. So here we'll be learning about as you have already learnt about the compilers in the previous part, that is part 1, part 2 and part 3. So here we have already dealt with respect to the statement of a problem and then how to recognize the basic elements. Then we need to identify the syntactic units and then you have to interpret them. And with respect to the intermediate phase, we have already learned about the arithmetic statements and then non-arithmetic statements. Apart from that, we have the storage assignment, code selection as well as the assembly phase. So now in the diagram, here you are going to see the different phases of the compiler, which we call it as the general structure of a compiler, wherein you have the lexical analysis phase, syntax analysis, then the interpretation section, and then apart from that we have the machine independent, that is nothing but we are going to deal with respect to the optimization technique. And next is the storage assignment, then we have the code selection, as when the last part is nothing but your assembly and then how you're going to output it. Now each of the phases are going to have the different tables or the databases which are being created in each of the phases and then how exactly each of the phases is going to work. Now with respect to the lexical analysis phase, we have the terminal table as well as the identifier table and then the literal table. With respect to the syntax analysis, we have the uniform symbol table. This uniform symbol table is also being shared with respect to the interpretation phase and the lexical analysis phase. And coming to the machine independent optimization, we have the matrices which are going to be created during the optimization phase, and the identifier table as well as the literal table are going to be specified with respect to how the storage assignment is being made during the allocation of your tokens. And then coming to the code selection, so this code selection is dealt with respect to how the code is being assembled so that it can be sent to the through the assembler to the loader in order to execute your program. Now coming to the phases of the compiler, that is the lexical phase. So in this lexical analysis phase, that's nothing but it is going to recognize the basic elements and then creates the uniform symbols. So there are mainly three tasks for the lexical analysis phase. The first is to parse the source program into basic elements or tokens of the language. Then to build a literal table and along with that an identifier table. And lastly, to build a uniform table. So these are the three databases which are going to be created during the lexical analysis phase. And then coming to the syntax analysis. So syntax analysis is nothing but recognition of basic syntactic constraints through the reductions. The function of the syntax phase is to recognize the major constructs of the language and then to call the appropriate action routines that are going to generate the intermediate form or the matrix for these constructs. So in some compilers what happens, this phase is implemented by one large program that is going to recognize each construct. So for example, if we choose a present general implementation, our syntax phase will be considered as an interpreter with general rules or the reductions that are going to define the major constructs of the language as well as the appropriate actions that are to be taken in order to construct for each construct. So there are nothing but the reductions which are going to be dependent upon the syntax of the source language and then it has to be modified depending upon the source language. Now coming to in this we are going to have the databases that's such as the uniform symbol table which is going to be created during your syntax phase. Now coming to the interpretation phase, The interpretation phase, that is nothing but defining of exact meaning and then creation of metrics as well as the tables by action routines. So this phase is typically a collection of routines that are called when you're going to when a construct is recognized in the syntactic phase. So the purpose of these routines is to create an intermediate form of the source program and then add in information to the identifier table. So the separation of the syntactic phase from the interpretation phase is nothing but the logical division. So the previous phase, it is going to recognize the syntactic constructs, that is nothing but the phrases which are going to be associated with a definite meaning, or the statements as well as the clauses, while the latter, it is going to interpret the precise meaning into the matrix or the identifier table. So in other words, what we can tell is, it may be an arbitrary to what size the phrase can be assigned for a meaning. And with respect to the interpretation phase, the databases which are going to be created during this phase are nothing but the uniform symbol table as well as the identifier table. And then we have a matrix which is going to be specified with respect to the two reasons. That is nothing but it allows the first four phases of the compiler to be machine independent, and then it allows independent optimization of the program to occur before the code generation phase. Now coming to the fourth one, that is machine independent optimization. As I have already told, it's nothing but the optimization technique which we have already dealt with respect to the previous sections. Here it is going to create a more optimized matrix, wherein again it creates the databases which we call it as a metric database that we have already explained. And then along with that, it is going to create an identifier table as well as the literal table. So in this, how exactly it is going to eliminate the common sub-expressions as well as the time which is required in order to, or the compile time which is required in order to compute the program. Now coming to the fifth phase, that's nothing but the storage assignment. So what is the storage assignment? It's nothing but it is going to modify the identifier as well as the literal table. So it makes an entries in the matrix that is going to allow the code generation to create code which is going to allocate the dynamic storage and also allow the assembly phase to reverse the proper amount of the static storage, that is nothing but the storage within your RAM. So what is the purpose of this phase is in order to assign the storage to all the variables which are going to be referenced in the source program, and also to assign storage to the temporary locations that are necessary for an intermediate result. So the results can be your matrix line. So these storage references were reversed by the interpretation phase and it will not appear in the source program. So what happens here, it is going to assign the storage to the literals and ensures that the storage is allocated and appropriate locations are initialized which are going to be specified for the literals and as well as any variables with the initial attributes. So the databases which are going to be created during the storage assignment phase are nothing but the identifier table, the temporary storage table, literal table as well as the matrices. Now coming to the sixth one, which we call it as a code generation. So the purpose of the code generation phase is to produce the appropriate code. That is, it uses the macroprocessor to produce the more optimal assembly code. So in this case, we have the different databases which are going to be created. That's nothing but the matrix, the identifier table, literal table, and then we have the code production. That's nothing but a permanent database which is going to define all the possible matrix operators. As you know already, the different operators are nothing but the plus, minus, into, and so on. So these are the four tables which are going to be created during the code generation phase. And finally, coming to the assembly phase, that's nothing but the last phase wherein it is going to assemble or resolve the symbolic addresses, and then it is going to generate the machine language. So the main task of the assembly phase depends upon how much it has been done in the code generation, and then it works on the code generation along with the assembly phase, which is going to resolve the label references in the object program, the format of the object deck, and also the format which is going to specify the appropriate information for the loader. So at the extreme, if the code generation has simply generated the symbolic machine instructions and labels, the assembly phase must resolve those label references, and then it has to calculate the addresses and along with the binary machine instructions which is being generated during the assembly phase. And lastly, it has to generate the storage and convert the literals. So in this phase, we have the databases such as the identifier table and the literal table along with the final output of the code generation. With respect to the different databases which are being used by the compiler, and then how exactly each of these are going to be communicating between the phases. So the first is your uniform symbol table. What is this uniform symbol table? So this uniform symbol table is going to consist of a full or partial list of tokens which are going to be appearing in the program. And this table is being created by the lexical analysis to represent the program as a string of tokens rather than of individual characters. So in this, we are not going to use the spaces as well as the commands in the source program which are going to be represented and are not being used by the uniform symbols. So there is one uniform symbol for every token in the program, and each of this uniform symbol contains the identification of the table of which the token is a member. So this uniform symbol table, which is going to be created by the lexical analysis and then used by the syntax analysis as well as the interpretation phases. The second one is your terminal table. Terminal table is nothing but a permanent database that has an entry for each terminal symbol. Example, an arithmetic symbol or an operator, keywords, non-alphanumeric symbols. So each entry consists of the terminal symbol, an indication of its classifications like your operator, break character, etc. and its precedence. So these will be used in the later phases. So that is being specified as terminal table, which we call it as a permanent table, which is going to list all the keywords and special symbols of the language in your symbolic form. What is your identifier table? So identifier table is going to consist of all the variables in the program and the temporary storage, as well as the information needed to reference or allocate storage for them, which is being created by the lexical analysis, modified by the interpretation phase, as well as the storage allocation, and then referenced by the code generation, and lastly by the assembly phase. So it is also going to contain the information of all the temporary locations that the compiler creates for use during the execution of the source program. So there is only one entry for each identifier. So the lexical analysis phase is going to create the entry and places the name of the identifier in that entry. So we have this respective functions which is being specified in different phases. Literal table. What is this literal table? So this literal table is going to contain all the constants which have been available in the program. So this literal table is being created by the lexical analysis to describe all the literals used in the source program. So there is only one entry for each literal, which consists of a value, a number of attribute, an address, which denotes the location of the literals at execution time, and along with that it contains other information. So, now the next one is the reduction. What is this reduction? The reduction is nothing but one of the permanent table which consists of the decision rules in the form of patterns for matching with the uniform symbol table in order to discover the syntactic structure. So the syntax rules of the source language are going to be contained in the reduction table, and then this syntax analysis phase is an interpreter driven by the reductions. Now coming to the matrix database, that is nothing but it's one of the major databases used by the optimization phase. So this optimization phase is a part of an intermediate form of the program which is being created by the action routines and then optimized and finally used for code generation. So this acts as a major database to facilitate the elimination or the insertion of the entries into the matrix. So here we are going to add to each entry the information such as the chaining, forward and backward pointers. So this avoids the necessary reordering or relocating matrix entries when an entry is added or deleted. The next is the code production. So this is also a permanent table which is going to contain all the definitions. So all the definitions which are going to be possibly available in the matrix operators. As I've already told, you have the different that is nothing but simple operators such as star, equal to, minus, plus, etc. So here it there is only one entry defining each code for each possible matrix operators. The next is the assembly code. As you already know, what do you mean by an assembly code? So this is nothing but the language version of the assembly language of a program which has been created by the code generation phase and acts as an input to the assembly phase. And lastly, we have the relocatable object code. This is being considered as the final output of the assembly phase, and it is being readily available for the loader as an input in order to execute the program.